Hey class, it's your TAs and we're here for the Hidden World of Lighting Lab to show you how to do it.
We're going to be providing the data for this lab, but we wanted to walk through some of the steps you would have taken if you were with us in WEI or Granger.
3, 2, go.
All right, so we're going to start our process with data collection. I have in my hand a temperature gun, but the first thing I'm going to do is I'm going to observe the light bulb. So Audrey, if you want to come over here. We can see that this is what I would think of as a normal light bulb shape, and it has a warm yellow glow to it. So next I'm going to feel it. Not going to get too close, but I can feel some heat radiating off of this light bulb. And when I use the temperature gun, we can see we have a reading of 184 degrees Fahrenheit.
That's so hot.
So one thing to keep in mind while we're reading all these instruments is a lot of them have different settings. So this temperature gun can read both in Celsius and Fahrenheit. And this device can read in a lot of different units. So this is our watt meter. It's plugged into the light bulb and it shows you how many watts are used by this light bulb. Right now it's actually set to volts. So the first thing I'm going to do is I'm going to change that over to watts. And I can see we are at 58.7.8 watts. It's okay if these fluctuate a little bit, but we are approximately at 60 watts. All right, so we want you to take a second and try and guess what kind of light bulb this is. All right, now you have your guess. We're going to look at this fun information sheet. So if you guessed that that was an incandescent light bulb, you are correct. This is our 60-watt incandescent light bulb. Some other important information that's on here is our brightness, which is kind of in this handy-dandy fact sheet. We have 870 lumens. Our estimated yearly energy cost is $7.23. It is a warm light, which we could tell just by looking at it. And the energy used is 60 watts.
You'll also notice that the life is under a year, which isn't that great. All right, we're going to use the infrared thermometer and take a reading of the bulb.
We're at 141.3 degrees Fahrenheit.
You'll notice that's a little bit different from our past bulb, and we're going to see some differences between bulbs, as expected. All right, so we're here with our second light bulb. Let's take a look at its color and its shape. That coil is really a key part of identifying this light bulb. If you're thinking it's a CFL, you're correct. All right, we're going to use the infrared thermometer and take a reading of the bulb.
We're at 141.3 degrees Fahrenheit.
You'll notice that's a little bit different from our past bulb, and we're going to see some differences. Now we're onto the watt meter. All right, taking a look at this, it's in volts. We're not measuring volts, we want to measure watts, so we can hit the watt button. 13.4. That's a lot different from the last one, which is good to know.
You can also see, just as we're observing here, a little HG symbol on our CFL bulb, which we will go into more detail about later.
All right, so you'll remember that the reading that we got on the watt meter was about 13.4, and that's close to the expected 14 used. However, it still does have the equivalent lumens, the equivalent brightness, as a 60 watt. And that compares to all the other light bulbs we're looking at today that are 60 watt equivalent.
And if we turn to the back, we can see this lightning fact sheet, and we can see again those lumens. The estimated yearly energy cost is only $1.69, which is down a lot from our incandescent bulbs. The lifespan is also a lot longer. The incandescent bulbs were only going to last for 0.9 years, and this has an 18.2 year lifespan, which is a lot better. And this also says that it contains mercury, which is what that little HG symbol stood for. That means that if this bulb were ever to break or anything like that, you would need to be careful in its disposal.
All right, we're on to the third bulb. So let's take a look at this one and guess what it could be. We've been through the CFL, the incandescent, and that leaves us with the
LED.
LEDs. And you'll notice this color is a lot different. And it's also significantly cooler. I'm not worried to put my hand close. I'm still not going to touch it for safety, but I'm not too worried about it. We do have the thing that says LED here, and so if you guessed LED, you are correct. It says soft white, but it is a lot different than the other colors we've seen before. Let's take a look with the heat gun.
And we are at 100.8 degrees Fahrenheit, which again is the coolest of all of the 3 light bulbs we've seen so far.
That's great. The coolness is definitely a helpful safety feature. And now we can look at the watt meters. Again, it's in volts and we want watts. There we go. It's at 9.3 watts. So looking at the energy fact sheet we have here, it says it only uses 9.5 watts, but again, it's that 60 watt equivalent that we're looking for. And it has a similar lumens as all the other 60 watt equivalents. All right, so we've got our energy cost yearly. That's $1.14, the 800 lumens. It is a warmer color appearance, supposedly.
And then another important thing is the life. This has a 22.8 year lifespan. If you remember from our last lab, one of the things we were comparing with the LED bulbs is their lifespan. So that's a really important thing when you're considering the overall cost of the bulbs and also the efficiency. So we've just finished our data collection for this portion of the lab. We noticed a lot of differences between these different light bulbs. One of the biggest differences was in the temperature. So for the incandescent bulb, we recorded a temperature of about 180 degrees Fahrenheit. And for the LED bulb, we recorded a temperature of around 100 degrees Fahrenheit, which is an 80-degree difference.
Using the watt meters, we also noticed a difference in the wattages that each bulb used. So for the incandescent, it used about 60, for the CFL, it used about 13.5, and for the LED, it used about 9.
Despite all these differences that we saw between the bulbs, we also noticed something in common. They all were producing about the same number of lumens, right around that 800 to 900 range, and they both looked about as bright when we were observing them. So in this lab, we're going to explore why those differences matter and where the extra wattage is going.